Hello everyone and welcome back to MrMiers Math Channel. Today we're going to talk about hyperbolas, which is section 13.5. Our goal is going to be to just graph hyperbolas. So there's a lot of different features of hyperbolas, and we're just going to mainly talk about the ones that will allow us to graph a rough sketch of the hyperbola. We're not going to get into very complicated things in this lesson. All right, so let's get started. All right, so in blue what you'll see is the graph of the function of the hyperbola. Now there's a lot of different features that you can see on this graph. There's a lot of information here, but we're just going to talk about enough to be able to graph the hyperbola or make a rough sketch of it. All right, so some commonalities between circles and ellipses would be that a hyperbola 2 also has a center. Okay, and we're going to see vertices, just like how we had with an ellipse. We had vertices there and co-vertices. We have vertices here. So each vertex is one of the points actually on the graph. And then notice that each vertex is the same amount of units away from the center. Okay, another thing that we're going to use, we're going to create this box here. So we're going to use each vertex to get the width of the box, and then we're going to use what's called b, I guess, in the equation to find the height of the box. Once we create that box, we can get our asymptotes. And remember those asymptotes are limiting branches. That's where our graph gets closer and closer to that line, but actually never touches it. So once we create our asymptotes and this box, we'll be able to form the graph of our hyperbola. So getting to the equation, we have two different hyperbolas that could happen. We could have a horizontal or a vertical hyperbola. A horizontal hyperbola would just be one that opens to the left and to the right. Vertical hyperbola would be one that opens up and down. Now, we're going to be able to tell whether it's a horizontal or vertical hyperbola by the equation. All right, if x is first, then it's going to be a horizontal hyperbola. If y is first, we're going to see a vertical hyperbola. One difference between ellipses and hyperbolas is you're going to notice the minus sign instead of the addition symbol. Okay, everything else is essentially the same, just that we could have y first or x first. Okay, it's not set that x is always going to be first like it was with an ellipse. All right, the center point is still the same. It's h comma k, and we're still going to find a and b, just that a doesn't necessarily mean how many units we're going to go to the right and to the left. Okay, it depends on the equation. If a is under x, okay, and a is always first, so if x starts the equation, or this hyperbola is a horizontal hyperbola, then this is going to say how many units we move to the left and to the right. However, if y is first, then a is going to tell us how many units we go up and down. All right, then b tells us how many units to move from our vertices to form the asymptotes. In other words, if a is going to the left and to the right, b is going to tell us how much to go up and down, and vice versa for a vertical hyperbola. All right, so let's really get into it here and get to our first example. We're going to draw the hyperbola given by the equation. So we start with the center. The center in this one is going to be the origin. Nice and easy to start with. Notice there's nothing subtracting from x, nothing subtracting from y. So I'm going to draw that little point. That's going to mark the center. Now we're going to find a and b. Now remember, a in this case for a hyperbola is always first, and then b is always second. So a is going to be 3 if we take the square root. B is going to be 2 if we take the square root. Now since this starts with x, this hyperbola is going to open to the left and to the right. Therefore a is going to tell us go to the left 3 units and go to the right 3 units. All right, these are actually going to be points that are on our graph. Those are 2 of our vertices. All right, now b is going to tell us how much to go up and down. So we're going to go up 2 units from each vertex, and I'm going to do this in a different color, because what we're going to be doing is forming our box. That's going to allow us to draw the asymptotes. All right, so we're going to connect the opposite corners to form those asymptotes. All right, so we could easily just think of it as, drawing a line, go up 2 over 3 to get from the center to this point, and we could just continue that process. Same thing going the other way, go down 2 over 3. I'm just going to go draw those points as guiding references. So there's one asymptote, and then do the same thing on the other side. So I'm going to go down 2 over 3, draw those just guiding reference points for this asymptote, and the same thing on the other side. All right. Now let's actually draw the hyperbola. So it's going to start at one of the vertices. And like previously with the ellipses and circles, we're going to kind of go a little wide here to start. And then it's just a general trend towards that asymptote, but just remember, we're never actually reaching the asymptote. Now this might not be what the hyperbola actually looks like in terms of where the points are on the graph. It's just giving us a rough sketch. If we wanted to do it a little bit more accurately, we could talk about more in-depth features of the graph, or we could use a graphing calculator or some kind of graphing device. This is just allowing us to get a brief and rough little picture of what this thing may look like. Oops, didn't go very wide at the top there. But that gives us a little picture of our hyperbola. Obviously, we're going to ramp up in difficulty as we go on. Now, this one's a little bit different. So notice nothing is happening to x, so that means the x value or the x coordinate of the center is going to be 0. Nothing's happening to y, so that's the same. So we're still at the origin here in terms of the center. But now y is first. Okay, since y is first, a is going to tell us how many units to go up and down, and that's where we're going to form our vertices. Because since y is first, this hyperbola is going to open up and open down. So a is 4 in this case, and b is 2. So a is going to tell us, let's go 4 units up, and there are going to be our 2 vertices. And now b is telling us, okay, now we're not going to go up and down still to form this box. We got to go left and right. So 2 units to the right, 2 units to the left, and that's for each vertex. We can form that box. And now we can connect the opposite corners to form our asymptotes. Same thing here. So I'm going down 4 and to the right 2 here. And then up 4 to the left 2, and drawing that final asymptote. And obviously it's a very rough sketch here. If only I had paper and a pencil and I could use a ruler. That would definitely help. Now with our vertices, we're going to draw the hyperbola. One side opens up. The other opens down. Now this is my poor graphing here. It doesn't actually get this close to the asymptote so soon in these locations. But we could use a graphing calculator to see how close it actually gets. But it definitely doesn't get that close to these asymptotes in these locations. All right. Now we see that there's something going on with x and y. So that means our center is going to be different. The center, for example 3, is the point 3, comma, -2. I'm going to draw that on the graph. Notice it starts with x, so it's going to open left and right. And then a squared is going to tell us, a is going to tell us how many units we go to the left and to the right of the center. So that would be 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right there. Now b is going to let us know from there how many units we go up and down. So we're going to go 3 units up and 3 units down, and that's going to be how we form our box. Oh, my tablet's a little off in its orientation. Now let's connect those opposite corners here. Okay. Oops. I need to draw that line, and for it to be a dotted line. And now let's draw the rest of the function. We have the right side, and then we have the left side. Awesome. Hopefully you're getting the hang of this. We're going to do just a couple more examples here. We're going to skip example 4 actually, and we're going to just move on to example 5. I don't want there to be too much repetition. I know there usually is, but we're going to skip example 4 and move on to the next one. All right, let's start by identifying the center. Now we've got to be careful in this one. It might be really easy to say 3, -2 as the center, but that's actually not the case. The center is not 3, -2. All right, what's happening to x is we're subtracting -2 units, and then what's happening to y is we're subtracting 3, so the center is actually -2, 3. All right, so that's an easy mistake to be made. Now, since it starts with y, a is going to say how many units we go up and down. So a is 4, so we're going to go 4 units up, 4 units down. And then b squared is 36, and b is going to tell us how many we go now to the right and to the left. That's 6. Go 6 units to the right of each vertex, 6 units to the left of each vertex. Draw that box. And then draw the asymptotes. And now let's finish drawing the function. This is going to open up and down, and this is going to be really wide. All right. Now, last example is example 6, and we're just going to differentiate between parabolas, circles, ellipses, and hyperbolas. Okay, so the key thing is to recognize the differences in the equations. So maybe for some, you might want to go through if circles are easy for you, just go identify all the circles first, then maybe move on to parabolas. I'm just going to go through it one by one and talk about why each one is what it is. So for number 1, we have, notice, only one of these quantities being squared. So in circles, ellipses, and hyperbolas, we have both x's, like the x and y being squared. So in this case, this has got to be a parabola. Only one of those variables are being squared. All right, if we take a look at 2, notice one key thing is that they're both being squared, but also that we have a plus sign in between. So that only occurs for circles and ellipses. However, for circles, this wouldn't have any denominator, and since it does, it's an ellipse. And then moving on to 3. Once again, it's the same thing. Both of these variables are being squared. This equation equals 1, which can happen for a circle. All that would take would be a radius of 1, but also we see a denominator there, so this has got to be an ellipse. For number 4, we see a subtraction. Almost automatically, we can say that this thing is a hyperbola. Both of these variables variables are being squared also. So this is an example that we could graph based on this lesson. All right, then 5, y is not being squared, but x is. That quantity is. All right, so that's a parabola. And then finally 6, we do have our circle. All right, both of these are being squared. There's no denominators. This thing is a circle. And also it doesn't equal 1. It's another indicator. All right, I hope this helped you understand how to graph hyperbolas and also differentiate, of course, between parabolas, circles, ellipses, and hyperbolas. If you found this helpful or enjoy the content, like, subscribe, share, and thank you and have a good day.